Hi. In this section, we're going to talk about data sampling and variation and data and sampling. And what we're really talking about is just the types of data we have for the certain types of variables we have and the different types of sampling. And so we can recall from the last section that we have different types of variables, right? We have a quantitative variable and a qualitative variable. And the qualitative is categorical, right? Categorical variable. And the quantitative is where we could take the data from the variable and find the average of, right? And apply arithmetic operations to get meaningful results. So in this case, we have the quantitative variable we're going to start with, and the quantitative variable has two categories, the discrete or continuous. So there's two types of data we could get that's quantitative. We could either get the ones that are countable or the ones that are continuous. So let's look at the difference. So a quantitative variable is said to be discrete if it has a finite or countable number of possibilities. Countable means counting in the natural numbers, typically variables that are counts. So we either have whole numbers, like the number of children in your household, right? So if we have a number of children in our household, like people in general, if we say we have 1.2 of a person, or I'm sorry, 1.2 people, that doesn't mean we have literally 20% of a person, right? Like we have the whole person. If I say I have 1.4 turtles, that means I really have two turtles. If I have zero point 0.4 of a turtle, I usually have the whole turtle, right? So anything that's countable, okay, that you can only count in whole numbers. And that would be like people, animals. If you go to the grocery store, you can't go to the produce area and buy an eighth of an apple. You can't cut an eighth of an apple and go to the register and say, hey, I have an eighth of an apple, charge me for it. They're going to be like, no, go back and get the whole apple. Why are you cutting our fruit up? And go buy the whole apple, right? So everything's just whole numbers. That's discrete. Continuous is everything else. So that's like distance, time. It takes me 2.4 hours to run a 15 miles, right? It's 98.6 outside, and so like there's all everything in between would be continuous, and so it's either going to be discrete because it's going to be whole numbers or continuous. Let's go ahead and look at the example given to us. So it says that these are going to be quantitative variables and that we want to classify them as discrete or continuous variables. So the number of children, right? We talked about that a minute ago. So that's like we need whole people, right? So that would be discrete. The household income in a previous year. Well, we definitely can have more than whole numbers, right? We could have made 200,085 cents last year, right? So this would be continuous. Daily intake of whole grams. So the word whole grains. So the word whole grain just means it's a type of food, but can we eat 1.5 grams of grain? Can we eat 3.25 grams of grain? Yes. So this would be continuous. Okay. So quantitative has two types of variables. And so those two types of variables go hand in hand with the type of data. So if we have a quantitative variable, we have quantitative data. If we have categorical variables, we have categorical data. So we just have the names of the variables to correspond to the type of data. So if we look at the example below and say we went to a supermarket and purchased 3 cans of soup, we had 19 ounces of tomato bisque, 14.1 ounces of lentil, and 19 ounces of Italian wedding. And then we bought 2 packages of nuts, 4 different kinds of veggies, 2 desserts, which are 16 ounces of pistachio ice cream and 32 ounces of chocolate chip cookies. So let's go ahead and name data sets that are quantitative discrete, quantitative continuous, and qualitative. Okay, so let's go ahead and begin with the qualitative, which is categorical too. It's however you really want to remember it, but they're both used synonymously throughout the book. So the qualitative would just be categories. What were the categories of the food we purchased? Okay, so it would be the types of soup, right? The types of nuts, the types of veggies, and the types of desserts. Right, so it would be like the names of or the types of categories for that particular food. Like nuts have a lot of category. There's walnuts, pistachios, peanuts, right, and so on. So quantitative would be everything that has a number associated with that we could find an average of. Can I eat an average number of ounces of soup a week? Yeah, right? So let's start with the number of right? And then we could say ounces of soup, right? Ounces of dessert, which was the ice cream. And then we have the number of, here, how about the number of cans of soup and the number of packages of nuts? How about the number of veggies we got? How about the number of desserts we got? And so we could see that we have 2 types of quantitative data. We have quantitative continuous and quantitative categorical. Quantitative discrete. And so for the number of cans of soup or the number of ounces of soup or the number of ounces of dessert, ounces, I could find an average number of ounces of soup I eat. Could I eat an average number of ounces of ice cream? Yes. So these would be continuous. And it's continuous because could I have maybe 14.1 ounces of soup and then another one have 19. So same thing here with quantitative. If the number of cans of soup is quantitative because could I eat an average number of cans of soup a week? Yeah, I eat an average about 2 cans of soup a week. Could I have an average number of desserts I eat a week? Well, yeah, I eat an average number of maybe 5 desserts a week, right? So you can still find the average of, right? Their arithmetic operations on the data have meaning to it. However, could I have an average of 1.2 cans of soup? Could I eat 1.5 veggies, right? So the number of cans, right? This isn't weight, it's just the number of the type of packages. So this would be discrete. Okay, so we did talk about quantitative, right? We said that quantitative had 2 types of data, right? But what about qualitative, right? What about qualitative? How do we deal with qualitative data? Well, let's go ahead and look at it. So I went ahead and just put like a qualitative data kind of discussion. It's really not a work. We're not going to do much math here, but we need to really talk about how we work with qualitative because we're never going to find an average number of hair colors, right? Or zip codes. So let's look at this little cool fall term 2007 census from the colleges of De Anza College and Foothill College. So we can see that the number of full-time students is 9,200 part-time total for each campus, right? And we can see that the number of full-time students at De Anza is much greater than the ones at Foothill. And the part-time is greater at Foothill than at De Anza. So we could see there's a lot more students, maybe less likely to work. I don't know. So because most students who are part-time tend to have other responsibilities like working or children or something like that. So let's go ahead and look at a pie chart. A pie chart is one way that we could look at categorical data. Okay, and here we could see that just from the pie chart itself, we could that De Anza has more full-time than Foothill, right? And less part-time than Foothill. And also we could see that essentially they're broken in percentages, right? So here they use the percentages and then use the colors for the category. So here, notice the categories are listed to the right. So they're not numbers, right? They're saying here's a category of part-time students and here's a category of full-time students. So the next way is the bar graph, right? That's another way, right, way number 2 that you can present categorical data. So you can, again, your x-axis will be the categories of the colleges, and even the bars itself would be the categories. And these bars and the numbers attached are just the counts. So we could see once again that the number of part-time students at De Anza looks like it's more than Foothill, and same with De Anza. De Anza looks like they just have more students, right? But proportionally, if we come back to the pie chart, we see that proportionally Foothill has less full-time and more part-time students than De Anza. Just because De Anza has more students, it doesn't necessarily mean proportionally they have more of that category. So we can see that even though the number of part-time students in this one looks like there's more at De Anza than Foothill, and that's only because more students attend De Anza, but proportionally, if we look at the total number of students, we see that Foothill has much larger part-time population than De Anza. So the proportion of each category is important here, and the only way we're going to see that is if we look at the percentages. Okay.